Okay, so today we're going to work with continuous servos. And so these are basically so a servo is, the word servo can mean like a lot of things. In the context that we're using, usually they refer to like these kind of really small motors with encoders that have that like 0 to 180 degree of motion. And then there's variations of those same motors, like this little guy right here, I don't know if you can see on the camera, that have like speed control sorry, I lose my train of thought. Instead of angle control. Okay, and so that's basically the difference here. And so we'll be using those, and they go continuously instead of having that specific position. So let's go ahead and try. We're going to try controlling this right here. And so we're going to start by importing our servo library, which will say from servo import servo. And so I've got this servo connected to pin 7. I'm going to say pin equals 7. Okay. And what we're going to do here is we're going to basically control this, the speed of this. We'll try out some different speeds. So just this is an opportunity for you to test out like different speeds of it, stuff like that. So we'll say while true. Actually, do a try and except block. So try. And we're going to say while true. And this way we can shut it down when we're done. We're going to say, I'll do another try and except block, actually. And this way we can catch any conversion errors. Actually, before we're going to say input. We'll say enter a value between 0 to 180. 90 represents stopped. Okay? So basically, when we enter speeds, what we're doing is when we enter a value here, if we type in a 90, that's like represents like the middle position on the servo where you control the angle. For these continuous servos, 90 represents stops. Okay, 0 would represent all the way one direction, full speed one direction. 180 represents the full speed the other direction. Okay, and so we're going to try to convert this to an int. So we're going to say speed equals int speed. Say exception as e, print e, and then we will down here catch our keyboard interrupt, and we're going to say servo dot. What was our method for turning it off? We got off. Okay, so we're servo dot off right here, so that turns off, and we'll give ourselves time.sleep of 0.1 to make sure it has time to run that operation if it needs to happen, like in the back end. Okay, and now all we got to do is we're going to say servo dot write, and then we're going to pass that speed. Okay, so we're going to run it. All right, and let's go ahead and clean this up. Got to import time. Let's see. Import time. There we go. Oh, you might want to clean this up too. Sometimes if you're using the input, you got to press stop twice. I've got something I'm working on with that, but in the meantime, 90 represents stopped, colon space. Okay, there we go. And so let's enter the speed of 90. And so now what you're going to find out is because these are imperfect, 90 might actually be forward or backward just a little bit. So I'm going to run this. Oops. Not what I meant to do. Stop. Okay. 90, enter. Okay. And so it still thinks it's stopped. or it's stopped now. So let's do 180. And so that's all the way forward, all the way backwards, slower, really slow. Let's go like 105. Do 145, 175. Okay, and now we're controlling the speed of this thing. And you can see it's kind of going all over the place. Okay, and so this is pretty standard. Let's put it back to stopped. And there we have it stopped. Okay, and so we're going to be using this as kind of like the wheels on our next little robot here that we're going to make. And so your job right now is to get this up and running so that you can control the speed of it. And then I also want you to try to kind of do something with this here.